break to re-energize your brains. And I have only 40 minutes. Anil just told me that, right? To re-energize and then get your 100% attention. Can you do a very quick 2-minute exercise, right? Wherever you're sitting, we will do that. And the last thing he said was I was running a design thinking. So I'll do a very quick thing, right? Just do what I say, and then so when I say head, you put your hand on your head. Yeah, go ahead, don't be shy. Yeah, cool. Head is this, okay? Clap. Stomp. Awesome. It's a very simple instruction. Let's follow that. Stomp. Head. Clap. Clap. Head. Stomp. Awesome. Now when I say switch and clear, understand the instruction. When I say switch, you will do. When I say head, you will say clap. When I say clap, you will say stomp. When I say stomp, you will head. It's a circular. Get it? Okay. Switch. Head. Stomp. Head. Clap. Head. Clap. Now we'll switch. Okay, so we'll do this once more. Cool, I like the smiling faces here. We'll do it once more and then we will go on to the serious topic of blockchain. Head. Clap. No, I'm not switch. So, without switch, a simple instruction. Head. Hand. Sorry, clap. Clap. Stomp. Stomp. Clap. Head. Switch. Clap. Head. Awesome. Thank you guys, you've been wonderful. So, sweet. So you're all energized. You'll have 45 minutes of me time now. So that's great. So as Manish was saying, I lead the blockchain practice in India. We've been doing this for almost 2 years. Great use cases all around. The one which is very close to me is identity on blockchain. The reason for it is I was the chief architect in Aadhaar, and this was about 7 years back, right, when I was doing this with Nandan Nilekani. And it was a startup environment. Today it is run as an IAS with all the IAS officers, all the bureaucrats coming in. But at that time, we were all guys from US who had come down to help do those. So if I had blockchain 7 years back as mature as it is today, of course it is not fully mature, but with whatever maturity it is today, I think it would have been a great use case, right? And we will talk about it, why it is such a great use case for Aadhaar or for identities. And if you have questions, we will park it. At the end of the session, we will take those. So you have a pen and paper next to you. If you get questions, write it down, and then you can blurt it out at the end of the session, okay? Cool. So what we will cover is these 7 things. I know from morning you've done a very basic, you've gone through what blockchain is, but I'll do a very basic introduction on blockchain so that we are on the same page. With that, what will give me is, you'll all be on the same page and whatever I've learned out will make some sense. If it doesn't, then we'll have discussions over lunch. With that, let's take a journey of an iPhone, right? Let's say that the iPhone is done, it's designed and the order has been given to some companies in Taiwan and China and all of those, and they come, right? And then there is this supply chain nightmare, and more so with Apple because they want to keep it secret till the day of their launch, right? So how do they do it? Right? Today, if you take a simple thing, so there is an OEM, there is a warehouse. As soon as the OEM says, the manufacturer says the warehouse that I've done, there is some kind of system which is getting written, and there are 3 systems. There is the OEM system, there is the warehouse management system, and then there is the telco system, because iPhones are sold by AT&T, Sprint, and all of those. So there are 3 systems. Under those systems, there might be multiple. With this itself, it's complex to explain. Let's keep it at the high level that there are systems in there. So there are at least 3 instructions being written, right? And then once that is done, you have then the warehouse saying that I've done QC. And then there are systems written again to the multiple systems of theirs. And then you have warehouse telling telcos that it is ready and you can pick this up. And that is when the telcos would say, I have an SO.
sales order, I'll put in the purchase order in the sales order and so on. Again, there are systems written. And you get the point, right? If you keep on going, you have multiple systems, the flow is the same, you have a spaghetti of information being exchanged. And the new system comes in, and there is a store. There is a store system which also comes in, which they have to manage them. So there is a spaghetti of information which happens, which is very tough, and you don't know which is the single source of truth in this. Because if you go back to a telco, there is a different set of data sets. If you go back to warehouse, there is a different set of data sets. I don't know which one to trust. And if I want to get insurance on it, the insurance guys, between two guys would fight, there will be disputes, there will be reconciliations. That is where I think blockchain shines the best, right? If you have disputes, if you have reconciliations, blockchain is the perfect fit. Nothing can beat that. With that, let's say then we have this blockchain magic which comes in. With that, what would happen is, as soon as there is a message written, there is a new block which gets generated. And then this concept of what I see is what you see, right? And we could have, of course, privacy and security being put in. But when block 1 gets written, where everyone knows what is being done, block 2 gets written, block 3. It's very simple. It's written with consensus. It's written with understanding of what it is. So every party in the system knows what kind of data I can trust, who is writing that data, is this visible to me or not, and can I rely on that data. All of that happens without any problems because you have to just, let's say there is a dispute, and then the disputes can be easily managed because you know this data was written and this data is not being changed by anyone. It had some kind of consensus between two parties, at least two parties, before it's getting written. So that is how it helps you overcome a lot of problems. So then now I have a single source of truth which I can go back to blockchain and then say, okay, yeah, this was what it has done. So what are the characteristics which we are talking about? It is, number one, it's chronological. So step 1 happens with the date and time written, so I know the step 2 is after step 1, and so on and so forth. It's a chronological order so that there is no double spending. 2, it is distributed, so everyone gets what a part of it or the whole part of the lecture. 3, it is immutable. Though we say it's immutable, someone can go and change it. So the newer word I want to use is it is tamper-edited. So it is not tamper-proof, it is not immutable, it is just tamper-edited. So if someone goes and changes it, the entire chain breaks, and you know, hey, someone was trying to break that. So if you have a lecture, you can still go and change it, right? Because it's still a system and you still have admin access to it and stuff. So it is tamper-edited. 4th, it is consensus-based. So someone is forming consensus before writing it. There are 2 kinds of consensus, just keep that in mind, right? When I talk to the clients, few of my guys itself made that mistake, is saying that there's this network-based consensus which you guys had a wonderful talk about, proof of work, proof of authority, and all of those. That is a network-based consensus. It's very technical in nature. Only PhDs and guys who want to implement it should know about it, right? And it is just to make sure which is my next block. What is the transaction which is my next block, and that's fine. But there is this nether layer of consensus which you need to worry about, which is the business layer consensus, right? And that is more important to solve all the business use cases that you have, all the pain points. It's not solved by a network consensus. If you go and implement a POA or a POW, it is not going to help solve a business consensus. It is just a method to write the next block. So when I say business consensus, what is it is, I and you agree on something and we say, okay, this is fine, and we write it onto the block. And when we writing it on the block is when the network layer consensus come in play. Clear? So the next one is, it's near real time. So as soon as I write it, everyone gets it. Of course, if your network is bad, you get it a little later, but you get it eventually. That is why I said near real time, based on the network latency. And then finally, it is either private or public. Accenture, we don't really work on a public space, though we work for Tech for Good, which is all public space, and identity is one of them, and we'll talk about it. The final one, and then it's mostly private because our enterprises want to keep that to themselves. They don't want to create consortiums and stuff like that, which is very finally, it is pseudo-anonymity. So what I mean by that is, if I don't want to tell who wrote that, like, let's take an example, right? Aeroplane, everyone is traveled on a plane system. When you go and book or web check in, you know that there are seats which are vacant and the seats which are occupied. So, but you don't know who is occupied that seat. That is the pseudo-anonymity. So you can't, but you know it has been occupied, but you don't know who is occupied it. So it still gives you an information that the plane is almost full. I'm going to get a last seat which will take me time to get out. There will be a big queue of line towards the restroom and all of those. So, but you get enough information for you to think, but you don't know, and you're not violating the privacy and the secrecy and the competitive edge which you need. And that is what blockchain brings in, right? The competitive edge. You don't lose a competitive edge when you do good. So that is the basic of blockchain. I think 5 minutes to get on the same page. Cool. So with that, we get on identity. Before we understand identity, let's define identity, right? Because identity for everyone means something else to everyone. First important fact, identity is a human right by default, right? Speech, everything else comes later. You have the right to identify yourself anywhere in the world and say this is who you are. But that's a very cumbersome process. So when you say I want to identify, today there are only 2 ways to identify it. One, you have some kind of a paper document or something which an institute gives. It could be a government institute, it could be another institute or so, or it's mostly social based. If you're in a village, you don't need an identity card, right? There are only 100 people there, and everyone knows you by name. So you don't have to go and say, hey, I'm Deepak Lalan, and that means something. They know you are Deepak Lalan. So that is what it is. So it is one which is very institutionalized, where someone gives you some form of paper or digital nowadays to say what and who you are. And the second one is where social guys figure out that you are what you are and then say, okay, this is fine. So that is what identity is. There are 2 forms. One is physical, you carry your passport, your driving license and stuff like that. And the second one is digital, which is very common today, which is your username and passwords and Aadhaar, which is your basically putting your fingerprint and giving your face and so on. So those are the 2 types. Identity needed throughout your life. Even when you are dying or when your death comes in, you need an identity to give you your death certificate. So it is so important throughout our life now. The economy and the capitalism has made it so important that you have to have some kind of identity throughout your phase of life, from birth to death. And it is becoming very critical. As it's becoming critical, it gives you a great shift from going from physical to digital, right? You don't want any more of physical. The problem with physical is that you have to be there in person, giving some kind of a document with someone you trust. Let's say tomorrow war breaks in. Let's say war breaks in, and half of the country doesn't believe in the other half. Now you can't travel there because they don't trust the other country. So that means your passport that you have becomes invalid, right? Because it is based on some country's institution which the other country will never trust. So there is this kind of a problem which we might get in very quickly. But it is moving toward digital identity. Let me give you an example. Today, let's say, how many, show of hands, how many of you are from startup world? Yeah, very good. Good. So now if I want to build a new app, let's say, or a new system, do I want to build a new identity system? No, right? I'll just use Google or Facebook, and that's what most of them do. Even if I get into Airbnb or anything else, I have the identity being as service provided by Google. I don't have to worry about GDPR there, because here it's his problem. And so on, right? So the privacy is all of me, and there is, so it is becoming that way, right? So I trust Google, I say, okay, take my Google, and then there's this form of trust coming in saying that Google is asking me, hey, I heard this app or this website is wanting to sign using Google ID. Do you want to give it permission to use it? So I am in control. And I am saying that, okay, yes, no, and then it is just one password that I want to remember. Unlike today, which we have thousands of passwords and an app to manage those passwords and a password to get into that app. So it's becoming more tough as we go along. So let's take the example to explain this, right? And I just told you. So there is this sports medicine company, and I'm a user to that sports medicine company. Now I have to sign in into that website. So first what happens is sports medicine company, and there are hundreds which come in, and everyone promising that, hey, you treat my pill and you get 20% of your muscle in 10 minutes. Someone says, okay, you're not having any side effects and so on. So I don't know whom to trust. So first thing which the sport medicine company is going to do is go to some institute which we trust, which could be something like an ISO or an IFA or something like that, right? Which certifies such companies, says this is the certification, and we certify that we've tested these products and they are all fine. And as soon as that certification is done, the sports company uses that certificate. It's a very similar case with your education, right? You go and say, hey, I'm an MBA from a Harvard Institute. How do you trust that you are running? It's that certificate which is being given to you. And you, with all your pride, put it in a frame and put it on your office or in your house. So similar thing that sports medicine does. So when I log in and I want to associate myself with sports medicine, first of all I see this certificate, and then it collects my profile. It says, okay, at least at minimum, give me your name, give me your password, I'll store it in my local database, and you're trusting it to be that it will keep it safe. So another example, right, which is very common nowadays, is SSL. When you get into a website, if there is a red cross, that means the SSL certificate is not valid and you will not trust that. Google itself, Chrome and IE doesn't allow you to get into the website. It says error because it's found that out. Then you have to click a few more things. No, I trust it. I still have to go. So that happens. So there is an institute which you trust like a very sign of so telling you that someone is going to certify itself and do this. So that is a very basic premise. With that comes a problem, right? There is a cumbersome step which you need to follow if you're using a password. You have multiple of those. Sometimes you don't remember. You have to say forget password, you get a OTP, you log in and all of those. Second, there is a dependency on the sports medicine's website that you are dependent on it and hoping that they keep it safe. Unlike the Marriott and Star fiasco which happened day before yesterday, where they lost all their, I don't know how many of you have lost their points after that. No, okay, great. Then finally it is a single point of failure. So if that server gets hacked or gets compromised or goes down, you can't log in and you can't do anything and you can't do anything, right? Tomorrow you can wipe off the entire database and your entire history of what medicine you've taken is gone. So how do you go back and tell your doctor, hey, I took this and sports medicine and now I have this side effect? You can't do that, right? So you're very dependent on it. So it comes with challenges. It's very siloed. Today's identities are siloed. So if I have a passport, it is passport only. Though there is some kind of a trust saying that you can use your passport for identity and address, but you can't use it for anything else. You can use your driving license for your driving and your house address, but not for identity. So it's very siloed. You will have to have multiple identities for multiple kinds of proof which you need to give. And then it is very cumbersome. If you want a passport, you have to book. I don't know what is the waiting time, at least 2 weeks now, if I want a passport. You have to wait, you have to go, give him the papers, he says, hey, your name, here is something wrong in your address versus what is there, and so on. And it's very painful. And finally, it is very complex. can't use one thing for the other, and so on. So this gives you a great opportunity to make a case out of it, right? And everyone knows if there is a pain point, there is an opportunity. And these are the pain points which we talk about in identity, which gives you the pain point. So to create a system of identity, you need it to be more flexible in its nature. It needs to be available wherever it needs to be. It needs to be efficient. It needs to be it needs to be secure, and it has to have great interoperability. So if I go back and give it to someone else, he trusts it and says, okay, this is fine. Like Google, which is doing in some form, right? Google, Facebook is with their identity. So there is this great sense of opportunity coming out of this, saying that you can create a system of identity which is beyond the boundaries of its own organization and which gives you great control over it. So when you're creating a digital identity, it comes with these 4 P's of principle. So these are the principles, right? It needs to be personal. When I say personal, it's more to be unique. And second, more to be with you having the entire permission on what you want to give, what you don't want to give. Second, it needs to be persistent. That when I give it, it doesn't change its form. Do fingerprints change? For other, it does, right? So if you take an infant or image and then it becomes another, there is some change, but the change can be managed. But there is, so what I mean by persistent is that it needs to be permanent. It needs to be the same. So I can use that again and again over the course of your lifetime and say, okay, I can use this. One of those persistent things and which in the blockchain world is hashes. Right? How many of you guys know hashes? Sure, man? Okay, most of them. Great. I don't have to explain it, so I'm trying to get my 40-minute mark. Second, third one, it needs to be portable. Is passport portable today? Yeah, it is. I can take my passport wherever I want. But it is not very flexible. Right? I can't use passport for something else and so on, but I can still take my passport. So whatever identity, digital identity I do has to be portable. If I'm using Google and if I want to move from Google to, let's say, Facebook, it needs to be portable and say, okay, I can use it in Facebook too and so on. In digital world, it is still not very portable. If I put it in one system, it is still in that one system and stuck there. And if I have to move it, it can't be moved. And finally, it needs to be private. I have to keep it to myself. Is Aadhaar private? No? Okay, great. Why is Aadhaar not private? You've given away your fingerprint, which you can never change in your life, and you don't know who is going to take care of it, where it is. Do you guys know where it is? Can you revoke that today? Can you go back to the government and say, hey, I don't trust this system, I want to take my Aadhaar back, give me my fingerprint and delete all that? I can't do that. It's no more private. Because it's gone and it's out of your control, they can do what you want. Let me give you another example just to make this clear. All of us receive our mobile phones bill on a week. It comes in a PDF format and it comes with a password which is based on some simple algorithm, which is the first 4 characters of your name and the last 4 digits of your phone number, which only you know, but your friends can also know, right? This is very simple. If this file goes to someone else, he can figure it out. It's not going to be that easy. That's not so difficult. So what happens with this, right? You have a PDF, which, let's say, this deck is very important to me, and I give it to you guys. And I say, okay, I don't trust them, I'll put a password to it so that whoever wants can come and ask me the password and I'll give it to them. But as soon as I send this file, it's out of my control. Similar to Aadhaar. I can't revoke this. Second, there's a password to protect it, but I'm giving that password to one guy. Now I lose that control too. He can give that password to anyone in this room, and everyone will have a copy of it. I have zero control. So that is what I mean by private. So what's the next step? How can we revoke, make me control of it? That is when you have the solution which comes in play, right? We'll go back again to the sports medicine. Now what happens is, let's say there is this system, aka blockchain, where you write your attributes or whatever you want to be identified as onto the chain. And the first rule of thumb, don't write your personal data, PII, onto blockchain. And I'll tell you why. Today, there are only two differences between a hash versus an encryption. Encryption can be broken, and it will be broken, right? If you do a 16-bit encryption, my laptop can break it in 24 hours. If you make it 256, it will take me a few months, or maybe a few years. If you make it 1024, it's going to take me years. But with quantum computing becoming a reality, and this is the catch, I have my personal information on blockchain, and going back to my character of blockchain, it is a distributed network. So whatever I've written, anyone has a copy of it. If he is in his system, has a copy of my personal or PII information, encrypted, fine, but he has a copy of it. So let's say I have my fingerprint, I put it in the fingerprint, now you have a copy of that fingerprint. Tomorrow, when the quantum computing becomes reality, someone can decrypt it. It can be after 100 years, but they can still decrypt it. With a hash, it's one-way hash. If I say, this is my fingerprint, I take a template of that, and then create a hash of that template, put it on a blockchain, it's a one-way hash. No one can figure out what it was ever in there. Like, that's the beauty of hash, and that is why we use it in blockchain, right? So, going back, so I have my information put on a block. Now, that blockchain, in the blockchain, I have one block which has my identity, which is immutable. No one can change it other than me. Even if I change it, it's a new block. It's not that block which gets changed. Second, it is distributed, it's available everywhere. And it is, and permission is with me, right? I can say who has the permission to unlock it using the public key. Okay. I'm saying, okay, my public key which is available and I distribute it has a time to live. It can be available for a week, a month, a year. And if I want to make it unaccessible, I just revoke the key and no one can decrypt it. Cool. So, and then I just have to give the sports medicine guy the access to the blockchain. And he has to become a member of that and so on and so forth. And that sports medicine guy now comes onto the blockchain, takes whatever information and goes forward. And that is how we address this problem using the blockchain or digital identity on blockchain. Right? You still have a certificate and all of those. We are not saying you eliminate those. You still need to trust the sports medicine guy. Except that now you don't have those cumbersome steps. You're not dependent on him, not having your credentials on his database and so on. Now you have control. You let the sports medicine guy know when and how to use it. That is what is the beauty. Now take the same example and say Aadhaar. If you had control and you said, okay, I'm not storing or giving you my fingerprint data, you only have a hash of the data, and you can, once you give your identity and you want to authenticate, you convert it into a hash and you compare those hashes. And that should be good enough for you, right? So that is what I'm saying. And we could be in control and eliminate half of the controversies we have on Aadhaar today because of this. I wish I had this technology 7 years back, we would have eliminated this, right? But even with that, what we did was, and we will talk about it in another few slides, is that we changed that. And this is very important, right? We starts with being a decentralized identity. So it's called DID. So you create identities on a decentralized database. It can be blockchain, it can be Hadoop with shard databases and stuff like that, but it has to be decentralized so that everyone has a copy of it. And second, it is all based on blockchain IDs, right? You're creating IDs on blockchain because you want to have private key and a public key associated with it so that you have control. And then you have hashes which you can use and so we'll take another example and we'll walk through it. And I heard, the comments that you need to go in a bit in detail. So I will spend some time. So you have your attributes, your physical attributes you want to give, and let's take the sports medicine example. I want to tell them what my height is, what I'm allergic to, what is my run time for a 10K marathon, and then what is my marital status. And this is my basic information, right? And now what happens is, if I'm giving it to a hospital in some place in Europe, so he's collecting data. He's collecting only few data which he needs. He wants just to know what my height is. He doesn't know my allergy because he didn't find that or he didn't ask me. And he knows, and he's put my marital status as something else. Then there is another sports medicine company. He doesn't know what my height is. He is taking my allergy as something else. He has my 10K time, which I might have given it to him, and then he has my marital status as something else, which is not allowed here. Those are the things, right? There are all so much of discrepancies in because it's handled by different teams. The first problem of our identity, it is siloed. You have information, but they're all so siloed and exchanging. So we are still dependent. Okay, I have to put that. We are still dependent on them, and there is still an inconsistent data, right? So now if I put that in blockchain, what happens is I know what kind of data I put. Going back to the PDF example, I know what I'm putting in PDF. I'm putting it on blockchain. I have control. Tomorrow I want to make a change, a new block gets generated with a new version of it. So if you go back to the older one, it's still telling you, hey, this is the older block, this is the new one which is associated to it. You can go and refer that. And I've unlocked, I've revoked all the access which I need for the first block. So you always go to the second block. So that is what has happened, and anyone else can use it depending on whom I give access to. So that is how it works, and then I can give time to live like what I explained, that I can tell it to be available only for a week. I can tell it to be available only for one access, and I can revoke it whenever I want. So I have full control of that set of information which I want. And then we'll take it to a next level. Can I take another 10 minutes? Are you guys really hungry? No? Okay, great, thanks. 5 more minutes, then we have questions here. Okay, so this is a very interesting concept, and this is the next level, and there are companies working on it, and it's a great use case, right? Think of, I look very good. When I go into a bar, people ask me for my driving license because they want to know if I'm out of drinking age or not, though I don't drink. So when I go into a bar, I'm giving the driving license. When I give my driving license, I'm giving away all my information. I'm giving them my address, my full name, how much times I have been in an accident, and so on and so forth, right? And that's a very bad thing. Now, let's take it to the next level where you could avoid all of those towards zero knowledge. So what is a zero knowledge proof, right? And I'll come to this example, but before that I want to just tell you one more thing to just build this up, right? If you have, and how many of you show of hands play Sudoku or no Sudoku and love Sudoku? Okay, awesome, only few. The others will have to bear with me. So you love Sudoku, you love Sudoku, you solve the Sudoku. Let's say we have given you the level 9 puzzle of Sudoku and you solved it. And you want to tell your friend that, hey, and you have a competition with him, and you said, hey, I've solved it. The way you show him is usually you show the solved thing, and he knows all the answers, which you don't want to, because you want him to also work on it and make that happen, right? So zero knowledge proof is that how do I prove to the other guy that I've solved this Sudoku problem, but by not giving him the entire answer? So I give him a part of the answer, maybe one block, to prove that I've solved it. And when you solve it, you will see that our answers will match, because when you go to level 9 of Sudoku, the possibility is to get the same kind of answer is way, maybe 95%, right? So you know that block is going to You have a blind man and you tell him, hey, I have two colors of balls and I'm giving it to you. And the blind man can't see it. He has to just trust you. How can he trust you if he doesn't know you? That you're telling that there are two balls. He knows there are two balls because he can feel it, but he can't feel the color. So how does he know? Of course, today there are computer vision, and you went through an AI class before this, there is computer vision, but let's say there is no computer vision, you have to go. Now, how can I prove that there are two different colors? So the way in zero knowledge proof, and this is done through arithmetic and algorithms, is, and a very simple example, is the blind man actually holds the two balls behind his back. He changes the balls however he wants and continues to show whichever ball he wants to show in his right hand or left hand. He'll put it forward and say which color is this. So you tell him it is black or blue, and then he takes it back, changes whatever, takes it to it. And he knows what he's changing, right? Because he knows he had two different colors, so he's changing. He puts it in his left hand. And you still tell him that because he's changing that. So now he does this a couple of times, and the arithmetic rule is that anywhere between 15 to 28 times if you do that, random check, you know that about 98 to 99% of the time it is going to give you the accuracy. And this is being implemented today. And that is what zero knowledge is. So today I can have my identity proved without giving my entire thing away. Right? And for example, going back to my bar license, so I don't have to give him my driving license. I have to just tell him, he asks me if I'm of age, and my system tells him yes or no. And that is the exact thing without doing all of these. 7 years back we implemented in Nada. That is how we're protecting your stuff. If someone gives you a fingerprint, all we are saying as a response to the fingerprint is you're authenticated or not authenticated. There are only 3 responses. You're authenticated and you're saying who you are. You're not authenticated because something is wrong. And third, there is an error message saying that you didn't get the entire file or some network broke and stuff. We're doing some kind of this where we are saying that you will not give away too much of information. Right? You just put your Aadhaar number, your fingerprint, and you come back with one answer. Yes, no, answer. Right? So that is what is the excellent thing about zero knowledge proof. And you get a lot of benefits, and its benefits are increased. Right? A consumer can get it like us. Business guys can get it because it's giving away that risk to the, that's the beauty. GDPR with blockchain is a great use case. With GDPR, what happens is the businesses are being given the responsibility to keep that data safe and to let them know if you're using it somewhere. Now I put that entire data on blockchain and say, hey citizens, now you have control. You tell us if I can use it or not. It's a great stuff. So you're taking off the risk from a business and saying you have it, you run it, and you tell us if I can use it or not. It's an exact case where everyone wants saying that I have control and that will be what you need to give. So it's a great case for businesses saying that it is de-risking them from this privacy stuff. And then finally, the regulators, they know and they can see as things evolve, so they are also. And we have a great examples where we are doing all of these. Accenture is working with ID 2020. I request everyone to get into that site. It's called id2020.org, where with our research we have felt that there is 1.1 billion users who don't have identity. And if you remember, I said identity is a fundamental human right. Human right before speech, before everything else, is the right to identify yourself. And that is what we are trying to solve with ID 2020. Then we are doing things with DIF, which is a decentralized identity forum. We are creating a framework and we are using that framework. And the way we have created the framework in DIF, we have taken it to World Economic Forum and we have used it in something called as a known traveler. So as a traveler, you need to have with that, I thank you for your time. And there is this example which tells you about the hash and stuff which I just spoke about. But with not being the guy who stops you from your lunch, this is also important. Thanks for your time, and I appreciate it. And we are open for questions for guys who have noted.
Yeah, I think we have taking 3 questions.
Only 3 of it. Okay. Whoever raised their hand first.
Rajni, can you please rotate the mic?
And I'm available during lunch. You can ask me questions there. And I'm being told that I'm there for even 5 o'clock. Discussion chair here. Okay. Can you get the mics?
Sorry, please get the mic on.
We have a lot of hands, but
Yeah, just.
Hello, my name is Pavitra. I just wanted to understand, what is the blockchain concept you have used here? Is it like Ethereum or
so you can use any of those platforms. The idea is that you build a block, right? So you have to have decentralized identities, make sure that you're not writing your personal identified information, have the hashes of it, and then you can re-verify it through hashes and stuff. So you can use Ethereum, you could use Hyperledger Fabric, you could use Monax if you're a old school guy, and so on. So platform doesn't matter. It's just giving you a building block. It is a use case. It's a use case built on it, and if you go there, EIF is a framework, so we have used Ethereum and Fabric here to build the EIF framework. So
you have used hybrid?
You could use anything. So platform doesn't matter. Just the building blocks need to be set right.
And one more question here. How are you planning to, because as time comes to, as there is a huge data is stored across. Another question here, always asking, how are you going to store data? Because this is going to be enormous.
Correct. Like what I said, you don't store data, you store the hash of the data. So the hashes are going to be very strong, and the hashes are going to tell you that it is not tampered, and you can verify it saying that it is the right one.
So where you are going to track the data?
Usually you keep it with yourself. I can tell you what my passport number is, which you can put and then it does scan. But if I give you the hash of the entire data of that document and say this is the hash, like MD5, let's say it's as simple as that. And then when I give you the information, you can actually verify saying that whatever information the hash which I have is the hash of the current document which I have. If it matches, that means I'm not tampered with it and it is authenticated the way it is. And in this example, which I was going to talk to you about, we are saying there is an institute which can give you a certificate. You don't store the certificate, you can store the hash of that certificate. And for the certificate, you can go back to the institute and ask, let's talk about the power certificates, right? You don't have to go and say, hey, this is my certificate. Instead, you keep the hash. You can go back and say, Harvard, can you give me the certificate of Deepak Lalan? They give you, you compare the hashes of those two and say, okay, this is the right hash. That is how you do it. So that is why we keep it very light. We are talking about 1.1 billion identities on blockchain. So it's going to be crazy if you store it. And if you go to IO 2020, there is a video where we have this entire prototype ready. So the user has the control of the fingerprint and everything stored on his mobile or wherever this cloud is. And then he only gives the hash and the permissions to those hashes. We need someone here. I know you. I'm sorry, I'm not the guy who controls it. But lunchtime, you can, of course, I don't want to eat lunch. Yeah.
So I have a question related to GDPR.
Awesome.
So I have read
Yeah.
about GDPR. I read about GDPR as a blockchain. So one of the things is like you should have the person whose data is stored should have a permission to delete the data whenever it comes.
Correct.
So which directly means you cannot store on blockchain. So either you don't store your data on blockchain or store on a private blockchain. So
So there are two things as you clearly said. So I don't store it, and that is why I only put my hash there. And even if the hash is there, it doesn't matter, right? Because and then second, you're giving the control to the citizen, saying that I'm revoking all the keys. So even if you have my copy, it's one, it's just a hash. Two, it is you can't access it until you have a quantum computer to unlock it and stuff like that. So and then third is basically putting it on a private, so making it more secure that way that only people use. So.
Correct me if I'm wrong. So basically, when you say hash is irreversible, basically it means that it will take millions of years or something like to decrypt. Not just it is one.
It's not decrypting, it's just one-way hash for things, right? So if you only know exactly what was used to create that hash, that is when you can create that, and you can't figure out from a hash what was created, because that's how hashes work. And if you talk about
Basically, like collision is possible, but it might take more time. It's not like impossible, right? It's
correct, but you have to figure out what was that exact thing used. Yeah.
maybe not now, maybe quantum computing something else. It might be possible.
Everything is hackable and possible in this world. It's just time. Right? I understand it. It is not. Yeah, it is.
Can we have the last question before we go further? I think can we go on this side?
Yeah, we have one. This is nice.
This question is a yes and a no. That's it.
Yeah. Yes.
I'm a very business person.
Okay.
Just don't understand technical. So my question is, you're probably answering yes and no. Is hash hackable or can you crack it? Because I know with my private block I'll be very safe. But
Correct. Everything in this world is hackable. Right. Nothing in this world is not hackable. Let's be honest to ourselves. Today or tomorrow you will have systems which can hack it. But keeping a hash will not be directly putting something which you don't have control over. So that way I'm saying it's somewhat safe.
still not permanent.
Yeah, it's not like the other thing. Nothing in this world is permanent.
Thank you.
Awesome. Thanks a lot, and I'm here to take it all.
Thank you.